Hello everybody. Today we're going to use what we learned about mass and mole conversions and how that interacts with balanced equations to solve a mystery. So here I've got some baking soda. Baking soda, we figured out over the years, is sodium bicarbonate, and when it's in a recipe it often reacts with acid that's in the rest of the food and carbon dioxide is released. But the carbon dioxide maybe is also just released when it's heated, and that's what we're going to try and figure out. So sodium bicarbonate, when it's heated, maybe releases carbon dioxide in one of these three reactions. Maybe it releases water vapor, or maybe it releases hydrogen gas and oxygen gas. And that's what we're going to try and figure out. The common thing about all of these reactions is you've got gases that are leaving and solids that are left behind. So we can use mass to try and figure out which one of these reactions happened. So we can measure the mass of the initial sodium bicarbonate that we put in, and we can use a balanced equation to predict how much mass would be left over depending on which reaction happened, and then we assume that all of the gases leave. Oh, I have another solid hiding over here on this one. So the goal of this experiment then, or the procedure, is we're going to take 2 grams of baking soda and we're just going to heat it. So in order to make sure I get 2 grams, first I'm going to measure the mass of just this empty crucible. So 43.43. And I'll write in more details here, see if you can do it on your own, but let's look at object, I'm making a table, and mass. And first we have the empty crucible, and the mass is 43.43 grams. And then I'll look at crucible with the baking soda, and we'll see what that is. And then we'll look at mass after heating. So this is crucible with products after heating. And we will end up heating it for 10 minutes. So the procedure suggests that you do about 2 grams. So we'll see how much this adds. So our goal here is to get to about 45.43. So we're at 44 so far. 45, getting close. Add a little more. Yeah, 45.42. Can't get much closer than that. And it doesn't really matter if we get it exact anyway. And now I'm going to heat it. So I have my camp stove here. I'll slide into position. And we'll turn that on. And now we'll heat the crucible for 10 minutes. And obviously I'm not going to film that whole time, and then we'll take the mass after. Okay, the 10 minutes are up. Time to turn off the heat. And then we have to let the crucible cool for a bit before I can touch it and weigh it. Alright, it should be cool enough now. Let's slide it back here and measure the mass, and we're down to 44.66. Okay, so we should be able to get the total mass of the reactants by subtracting the empty crucible from the crucible with the reactants. And we should be able to get the mass of the products by doing the same thing, subtracting the empty crucible from the products. Also, we can figure out how much mass left the reactants to make the product, so how much gas left by subtraction here, and etc. And then we should be able to figure out which reaction happened. So I'll do that on the next page. Okay, now let's consider these different possibilities for the reactions given the data that we have. So first we need to balance an equation. You need a balanced equation because that is how you go between moles of the reactant and moles of the products. We need to know those stoichiometric coefficients. That's our mole ratio. So for this first one, I'll do it with you, and then hopefully you can do the other ones on your own. So let's see. Right now I've got one sodium, one hydrogen, one carbon, 1, 2, 3 oxygens, and 1, 2, 3 oxygens. So this one's all balanced with ones in there. So that's all we need to do for that one. And do I think this one is reasonable? I suppose. We could have carbon dioxide gas leaving behind sodium hydroxide. That's a strong base, but it wouldn't, it's not a fuel or anything, so it wouldn't explode. So it seems possible. That one seems reasonable, so I would go ahead and circle that one as a possibility. And then for number 2, use the mass of baking soda you started with initially. Calculate the mass of solid product that would be produced. Show all your calculations including units. So the way I would do that for this first one is I would write down the reaction again. And then I would go back and look at my numbers. So I had the sodium bicarbonate. I can figure out the mass by subtraction. So I've got 45.42 minus 43.43 that I had in the empty crucible. So that's 1.99 grams here. And I can do the same thing with the solid. So the sodium hydroxide would be 44.66 minus 43.43. So 1.23. And then the rest must have been the gas. So 1.99 minus 1.23, 0.76. And of course the gas just went into the air in the garage, so there's no way that I could measure that. But I could see, starting with this mass of the sodium bicarbonate, how much mass I would expect with the sodium hydroxide. So these are the actual masses that I got. And then the calculation would be the theoretical for the sodium hydroxide. So what I would have gotten if this was the reaction. So I'm going to start with the 1.99 grams of sodium bicarbonate, and I'm going to convert that to moles of sodium bicarbonate, and this is just like we did the other day. I'll need the molar mass in order to do that, and then my masses will cancel, and then it's a 1-to-1 ratio. So then I'll get my moles of sodium hydroxide, 1-to-1. So this step won't change the number at all, but it does change the units. And then I'll get my grams of sodium hydroxide from my moles. And we'll see what that gives us. So we need the periodic table here. So for the sodium bicarbonate, I need Na, which is 22.99, plus 1 hydrogen, so 1.008, plus 1 carbon, 12.01, plus 3 times oxygen, 16. So I'm getting all of these numbers from the periodic table. Sodium, hydrogen, carbon, oxygen. And that's to match the formula NaHCO3. So that's 84.008. I'll also need the molar mass over here for the sodium hydroxide. So again, the sodium 22.99 plus 1.008 for the hydrogen plus 16 for the oxygen, 39.998. Now I have all the numbers I need. The units I'll check. I can go ahead and do the calculation. So the sodium bicarbonate divided by 84.008 times 1 over 1 times 39.998 equals 0.947 grams of sodium hydroxide. So that does seem like a possibility. It doesn't exactly match 1.23. It's a little low, but it does seem possible. We could in fact calculate a percent yield. Oh no, wait a minute. No, this doesn't work at all. Because my actual is greater than my theoretical. So I made more solid than I would have expected. So 1.23 grams divided by 0.947 grams times 100%. So that would be 130%. So that's not really possible. There is one possibility though, if you think about it. Maybe the reaction just didn't go to completion and I have some of this reactant left. So maybe it's still possible. So what I want you to do now is go back and go ahead and write out the balanced equations and do the reactions for all of these, and we'll see which one looks the most reasonable.